Hello all, welcome to this video on microprocessors and microcontrollers. The topic of discussion today is addressing modes of 8051. An addressing mode is a way of locating data or operands. All the members of MCS51 family support an identical instruction set which is optimized for control applications. 8051 instruction set support 6 addressing modes, namely direct addressing, indirect addressing, register instruction, register specific or register implicit, immediate mode, and indexed addressing. The table here shows us the meanings of symbols that are used in the addressing modes of different instructions in 8051. Rn represents one of the registers R0 to R7 of the currently selected register bank. Direct represents 8-bit address of either the internal data RAM or SFR register. At the rate of Ri represent the 8-bit internal data RAM address addressed indirectly using one of the registers R0 or R1. Hash data represents 8-bit immediate data present in an instruction. Hash data 16 represent 8-bit immediate data present in an instruction. Address 16 represents 16-bit destination address which is used by lcall or long jump instruction to specify the call or jump destination address within the 64 kilobytes program memory. The label of the jump address may even be directly specified in the instruction in place of the address. Address 11 represents 11-bit destination address used by call and absolute jump instructions to specify the respective call or jump addresses within the same 2 kilobytes page size of program memory in which the first byte of the instruction lies. The label of the jump address may even be directly specified in the instruction in place of the address. REL is a signed 8-bit offset in 2's complement form used by all the conditional jump instructions. It ranges from 128 to 127 from the first byte of the instruction. The negative offset indicate a backward jump while the positive offset indicate a forward jump. The label of the jump address may even be directly specified in the instruction in place of the address. Bit is a direct accessible bit either in any of the bit addressable special function registers or the bit addressable area of the internal 128 bytes RAM, that is from 20H to 2FH. Now let us move into the different addressing modes. First one is direct addressing. In this mode of addressing, the operands are specified using 8-bit address field in the instruction format. Only internal data RAM and SFRs can be directly accessed. For example, move R0, 89H. Here 89H is the address of a special function register T mode. Next is indirect addressing. In this mode of addressing, the 8-bit address of an operand is stored in a register and the register instead of the 8-bit address is specified in the instruction. Registers R0 and R1 of the selected bank of registers or the stack pointer can be used as address register for storing the 8-bit addresses. Address register for 16-bit addresses can only be the data pointer, which is DPTR. An example of this is add a comma at the rate of R0, where at the rate of R0 will represent the address that is indirectly specified. Next is register instruction. In this addressing mode, operands are stored in the registers R0 to R7 of the selected register bank. One of these 8 registers is specified in the instruction using a 3-bit register specification field of the opcode format. A register bank can be selected using 2 bank select bits of the PSW. An example of this is add a, R7. Next is register specific instruction. Here, the operand is implicitly specified using one of the registers. Some of the instructions always operate on a specific register. All of them fall under this category. An example of this is RLA, which rotates the accumulator left. Next is immediate mode. Here, an immediate data, that is a constant, is specified in the instruction after the opcode byte. An example of this is add a, hash 100. Here the immediate data 100, which is a decimal, is added to the contents of the accumulator. For specifying a hex number in this type of instruction, it should be followed by H. Last, we have indexed addressing, where only the program memory can be accessed. Basically, this mode of addressing is accomplished in 8051 for lookup table manipulations. Program counter or data pointer are the allowed 16-bit address storage registers in this mode of addressing. These 16-bit registers point to the base of the lookup table, and the accumulator register contains a code to be converted using the lookup table. In other words, it contains the relative address of code in the lookup table. The lookup table data address is found by adding the contents of the accumulator with that of the program counter or data pointer. In jump instructions, the contents of accumulator is added with one of the specified 16-bit registers to form the jump destination address. Examples are move C A, at the rate of A plus dptr. Here, move C copies the 8-bit data from internal or external code memory to the accumulator. Another example is jump at the rate of A plus dptr. That's all for now. Thank you. Thank you for listening.